It is a special privilege to introduce Dr. Christine Ortiz, MIT's Dean of Graduate Education and Professor of Materials Science and Engineering. Dr. Ortiz directs an award-winning lab in nanotechnology. Her distinguished research record is reflected in over 150 publications in leading scientific journals. She has also enjoyed extraordinary success in nurturing the careers of many accomplished students who work under her mentorship in her research lab. Please join me in welcoming Dean Ortiz.
Welcome. It's wonderful to have you here. I just want to give a warm welcome to all the contestants, your families, and congratulations for pursuing math and all the equivalent fields. I want to thank the Advantage Testing Foundation, including, we just heard from its president, Arun Alagappan, for founding this amazing prize and for motivating all of you to pursue math. I also want to thank the Akamai Foundation and its founder and MIT faculty member, Tom Layton, for supporting the prize, as well as Michael Sipser, an amazing department head in our math department. So, as you heard, I'm a professor of materials science and engineering at MIT, and many of you might be asking what that is. Materials science is a field that studies a whole array of different types of materials, and my specific research is on biological tissues. So I work on musculoskeletal tissues, cartilage and bone, and looking for how to create clinical treatments and understand diseases such as osteoarthritis. And on the other side, we look at exoskeletal materials. So these are the exoskeletons of animals. And so if you were to pass by Building 12, hopefully you're starting to get a little bit of the numbers at MIT. Building 12 is actually right across the street. My lab is in the basement of this lab, a very unassuming lab. And if you were to walk in, you would see giant aquariums filled with all kinds of interesting animals. You probably wouldn't have thought about that as a material scientist. And what we are trying to do is understand how animals protect themselves and design a exoskeleton for human protection, as well as for sports and even fashion. And I would say that throughout my career in science and engineering, that math was an underlying foundation. It's the language that sort of gives rise to everything else in the world. And there's no way that much of science and engineering, I would dare say all, could be achieved without an understanding of that fundamental language. And so in my daily life of doing research and in the lab, we speak the language of math every single day. We do simulations, we do analysis of data, we look at and when we look at these animals and how they move and how they're designed, they are sort of converted into mathematical formulas in our mind, as well as visually the beauty of nature. And I think that also underlies a lot of the beauty of working with math. So I thought I would just say a few words on why I love being a scientist and an engineer, and also why I love having math as part of my daily research. And as many of you, and you will see it will grow, is that I love doing projects. I love growing creative ideas. I always want to answer the question, why? And math is a key part of answering that question, why? I love exploring the fundamental laws of nature and seeing how they can be applied to new technologies to better the world that we live in. And I would encourage all of you to continue along the path in science and engineering, because it gives you a way to pursue what you are most interested in, what you're most passionate about. It gives you the opportunity to create your own pathway. It's challenging, it challenges your mind. In many cases, you can struggle for weeks trying to think about a problem. But when the solution comes, when there's that breakthrough, it's amazing. And it's worth all of the challenge that you faced all that time. And I would just say that eventually, it's not a job anymore, your profession. It just becomes fun. The best thing about being a scientist and an engineer is that today, that you can have just a huge impact on the world and on your fellow humans. It's truly a time where, with advances in computation and instrumentation and communication, that really anything is possible. And I see this with our students at MIT, and I would even say, I see this every day with students at MIT where they are having a global impact on the world, a positive impact, and I would say that the age is moving down, and it may get to you. So I would encourage you not to constrain, your thought in what is possible. So it's an amazing opportunity, and I just think that, again, that math runs through all of our disciplines. Any sort of device you can think of, the iPod, the smartphone, the GPS, Google, there's math underlies it. It's transformed lives. It's saved lives through medicine. Many of the technologies that we've developed at MIT, again, have this underlying foundation. And so it's wonderful to have you all here at MIT. I hope I will be seeing you in a few years as students on campus. And wherever you go, I wish you all the best in pursuing what it is that you're most passionate about. And I hope to see you all here in a few years. Thank you very much.